Welcome to this explainer. Today, we are going to thrust you into a seriously terrifying but fascinating thought experiment. We're going to uncover what time actually is by asking one simple, universe-breaking question. What physically happens if someone hits the universal pause button?
So, picture this. The world around you suddenly freezes completely. The coffee you're pouring just hangs there in midair. That bird outside your window is completely stuck in flight. It sounds like an awesome sci-fi superpower, right? You could wander around, fix your mistakes, or maybe just take a really long nap. But actually, if you stop time right now, you wouldn't be a superhero. You would be in instantaneous, profound danger.
Here's the deal. If time halts, all motion halts. And the very first thing to go? Photons. Those little carriers of light completely freeze. So, no light is hitting your retinas, which means, boom, you're instantly and completely blind. Second, the air molecules around you, which are usually buzzing around freely, lock up into this totally solid, impenetrable wall. You literally couldn't take a single breath. You'd suffocate. And it gets worse. The fundamental forces that hold reality together, they just quit. Electromagnetism and the weak nuclear force rely on the exchange of microscopic particles moving back and forth. If those particles freeze, your very atoms literally lose their structural integrity. Even gravity loses its time component and stops pulling objects together. It would be a total catastrophic physical failure.
Now, you might be wondering, wait, why does just pausing the clock cause such immediate violent destruction? Well, it all comes down to one absolute truth. Time is intrinsically tied to motion and change. In physics, motion is mathematically defined as a change in distance over a change in time. If you make that change in time zero, motion becomes physically impossible. You literally can't have one without the other. They are two sides of the exact same coin.
To put this into perspective, let's look at how we actually measure time. The International System of Units doesn't define a second as some magical, invisible tick of the universe. No, it defines a second strictly by movement. Specifically, it's the duration of over 9 billion microwave oscillations of a cesium-133 atom in a vacuum. Think about that. Time is literally defined by how much a specific atom wiggles. Meaning, without that physical motion, our very ruler for measuring time vanishes. If the atom stops oscillating, the second simply ceases to exist.
And this realization completely shatters centuries of scientific debates. For the longest time, mostly thanks to Sir Isaac Newton, we thought of time as absolute, like this independent, invisible background clock ticking away equally, totally unaffected by what's happening. Newton thought even in a completely empty universe, time would keep passing. But our modern physics and the utter destruction in our frozen universe thought experiment completely wrecks that Newtonian view. It actually aligns perfectly with what Aristotle figured out way back in ancient times: relational time. Aristotle hit the nail on the head when he argued that time is just a measure of change, completely dependent on physical processes. Bottom line, no events, no time.
As our sources highlight, time isn't some physical object you can grab or stick in a jar. It's a completely abstract concept that we invented. It's basically a conceptual ruler that we hold up to track the sequence of cause and effect. If every single thing in the universe suddenly stopped moving, there wouldn't be any cause and effect anymore. Our little ruler would have absolutely nothing left to measure, making time itself completely irrelevant.
Centuries ago, the philosopher St. Augustine took this idea even further, and it's super fascinating. He argued, quite beautifully actually, that time mostly exists right inside the human mind. He called it a distension of the soul. Think about it. We use memory to hold on to the past, attention to experience the present, and expectation to build the future. Under this lens, if consciousness stops, or if you just remove the observer from the equation, well, time itself might just vanish along with it.
The end of change. Does time exist if the cosmos stops?
So, let's zoom out from just human perception and look at the entire cosmos. Physics actually points toward a very real, highly theoretical scenario for our extreme cosmic future, called the heat death of the universe. We started with the Big Bang, right? A state of super low entropy and high order. But as the universe expands, entropy, which is basically a measure of disorder, just keeps increasing. Eventually, trillions of years down the line, it maxes out. All the energy gets perfectly, evenly distributed, black holes completely evaporate, and we enter what's known as the dark era. Just this incredibly dilute gas of particles, drifting so far apart they can't even interact with each other anymore.
In this massive state of perfect thermodynamic equilibrium, there are absolutely zero temperature differences. No stars are burning, no chemical reactions are happening, literally no events can occur. And like we learned earlier, without events, time means absolutely nothing. When there isn't a single physical process left to distinguish the past from the future, the arrow of time just completely disappears. In the dark era, 1 second and 1 trillion years are exactly the same. For all intents and purposes, time has naturally completely stopped.
But here's where it gets really wild. The mystery goes even deeper than the end of the universe. It's actually baked right into the foundation of modern physics. It creates this massive headache called the problem of time. See, we have two amazingly successful frameworks for understanding reality. On one hand, general relativity tells us time is super malleable. It stretches and warps around black holes and fast-moving objects. But on the other hand, quantum mechanics treats time as this absolute external ticking clock. And when physicists try to smash these two theories together to understand the whole universe using something called the Wheeler-DeWitt equation, they hit a mind-blowing mathematical wall. At the ultimate cosmic level, the time variable literally equals 0. It just completely vanishes from the math.
This crazy mathematical vanishing act points toward what physicists call the block universe model. This is a total reality bender, where the past, the present, and the future all exist simultaneously. Imagine a giant block of ice, right? And inside that ice, every single moment in history is permanently suspended. In this model, the universe doesn't happen or unfold in some temporal progression. It just is. The whole thing is just one completely static, frozen, four-dimensional structure.
When we look at advanced analyses of equations like this one, we see what physicists refer to as a frozen formalism. To make the math actually work for the entire universe, the equation maps out all the possible ways the universe can exist, but it doesn't give us any law of motion between them. It basically describes a state of perfect equilibrium where everything, and I mean everything, including time, is totally static. It's essentially the mathematical shadow of a cosmos where time isn't changing at all.
Which leaves us staring at a final, incredibly provocative question. We started all this by asking what happens if time stops. But if time is really just a human tool we use to measure motion, and if the cosmos is fundamentally just a static four-dimensional block, and if the ultimate math of quantum gravity literally equals 0, is time already stopped? Is every single thing you're experiencing right now, that flow from 1 second to the next, just a grand illusion created by your brain moving through a totally frozen reality? It's a pretty wild thought to chew on as you step back into the flow of your day. Thank you so much for joining me for this explainer, and definitely keep questioning the universe around you.